Namaste, my dear coding enthusiasts. Welcome back to our channel. Today, we are embarking on a truly exciting and advanced journey into the world of decentralized applications using Java. Our topic is Ethereum and Web3j for Java. If you are ready to connect your robust Java applications to the powerful Ethereum blockchain, then you are in the right place. We will explore how Web3j, a lightweight client library, allows Java developers to interact with Ethereum nodes, read data, and even send transactions. This tutorial is designed to be beginner-friendly, even though the topic is advanced, so we will break down every concept step by step. By the end of this session, you will have a solid understanding of how to get started with building your own decentralized applications using Java and Web3j. So, grab your virtual whiteboards and let us begin this fascinating exploration together. Alright, let us dive into our first core concept, connecting your Java application to an Ethereum node. Think of an Ethereum node as a server that holds a copy of the entire Ethereum blockchain. To interact with the blockchain, your application needs to establish a connection with one of these nodes. Web3j makes this incredibly straightforward. We primarily use the Web3j class and an HTTP service to point to our node's address. This address is typically HTTP localhost 8545 if you are running a local development node like Ganache or Geth, or it could be a public Infura or Alchemy endpoint for production. Once connected, you have the gateway to the Ethereum network open for your Java application. Remember, this connection is the fundamental first step for any Web3j interaction. Without it, your application cannot communicate with the blockchain. Let us see the simple yet powerful code to achieve this connection. Now that we have established a connection to an Ethereum node, let us learn how to read data from the blockchain. One of the most common tasks is to check the Ether balance of a specific Ethereum account. Web3j provides convenient methods for this, such as ethGetBalance. This method takes the account address and the desired block parameter, for example, default block parameter name.latest to get the balance from the most recent block. It is important to remember that most Web3j calls are asynchronous, meaning they return a request object which you then send to get the actual result. This non-blocking approach is excellent for performance in modern applications. The result will contain the balance, which is usually in WEI, the smallest unit of Ether. You will often need to convert this WEI value to Ether for readability. This process demonstrates how easily you can query the blockchain for vital information directly from your Java code. Excellent! We have connected to a node and read data. Now, let us tackle a more advanced and practical example, sending an Ether transaction from one account to another. This involves several crucial steps. First, you need to load the credentials of the sending account, typically using its private key. Remember, private keys are highly sensitive and must be handled with extreme care. Next, you construct a raw transaction object, specifying the recipient, the amount of Ether in WEI, and gas parameters. After creating the raw transaction, you must sign it using the sender's credentials. This signature proves that the sender authorized the transaction. Finally, You send the signed transaction to the Ethereum network using Web3j.extender The network then processes it, and if successful, the Ether is transferred. This entire process demonstrates the power of Web3j in enabling your Java application to perform complex, state-changing operations on the blockchain. As you venture into developing with Web3j, you might encounter some common pitfalls. Let us discuss a couple of them and how to avoid them. A frequent mistake is making blocking calls for network operations. Many Web3j methods return a request object. Calling send directly on it will block your thread until the response arrives. For better performance and responsiveness, especially in server-side applications, always prefer asynchronous processing using completable future or reactive programming. Another common challenge is managing gas fees. Transactions on Ethereum require gas, and incorrect gas limits or prices can lead to failed transactions or excessive costs. Always estimate gas requirements using Ethestimategas before sending a complex transaction. Lastly, never hardcode or expose private keys directly in your code. Use secure environment variables, key stores, or hardware security modules. Adhering to these best practices will lead to more robust, secure, and efficient decentralized applications. And there you have it, my brilliant Java developers. We have covered the essentials of interacting with Ethereum using Web3j in Java. We started by understanding how to connect to an Ethereum node, then moved on to reading account balances, and finally, we explored the crucial process of sending an Ether transaction. Remember the key takeaways. Web3j simplifies blockchain interaction. Most operations are asynchronous, and security, especially with private keys and gas management, is paramount. The world of decentralized applications is vast and full of opportunities, and with your Java skills and Web3j, you are now equipped to be a part of it. Keep experimenting, keep building, and never stop learning. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting programming content. Until next time, happy coding and stay curious.